Alright, so here's my project. I did it on a Kaggle notebook. First I have loaded the dataset as a CSV, and next we are, so mainly, let me scroll down here. So since this is a problem that, we're trying to predict the electrical energy output based on ambient variables, I determined that it's a regression problem. So with that, I wanted to try out linear regression, decision tree, and random forest, which are all suitable for regression tasks. And then the chosen output metric is the mean squared error. It measures the average squared difference between predicted and actual values. So we're trying to, ideally we want the lowest MSE value for the cost or error, whichever terminology you want to use. The features that are used in the model seem to be ambient variables. So the features are temperature, ambient pressure, relative humidity, and exhaust vacuum. So I'm now gonna get into the actual training here. So the first one, I'm doing a linear regression model here. Here I'm selecting all of the columns except the PE, which is our target variable, and setting them as the X values. Here I'm selecting a test size of 0.2, so it's a 80-20 split, and just selecting a random state. Train the model, and I got a mean squared error of 20 in that, and then trying out with a decision tree regression. And then we can see that the MSE is a little bit lower. Next, looked at the random forest. Clearly the random forest has the least MSE value, so and then I also did cross-validation and kind of compared. I did 5-fold validation here, just for simplicity's sake, but we can do as needed there. And then when I did this, it's still the random forest model that had the lowest MSE. Here it's 12. We got 10 earlier, but yeah, I've added some explanations onto these functions here. Yeah, basically the code uses cross-validation for comparing different models, and cross-validation helps to obtain a more reliable estimate of the model's performance using multiple subsets of the data for both training and validation. And yeah, the code compares the performance, and we identified that the random forest to be the best model, because we were going after figuring out the best model based on the lowest mean squared error. And yeah, there you go.